everyone, this is a Math OD2 video. This is on Chapter 3, Section 1, and we'll be discussing rules of exponents. So the main three rules of exponents are the product rule, the quotient rule, and the power rule. Now, as you can see, this chart has broken down the power rule into three different rules, okay? But really, there's only one power rule, which is this first one here. The other two are sort of extensions of the same rule, so we can really ignore these, okay, and just focus on product rule, quotient rule, and power rule. So this video is just going to focus on the product rule. So the product rule states that if I have the same base here, that's the key, a to any value, and then so a to the m times a to the n, I can resolve that by adding the exponents. So let's actually take a minute and prove this to ourselves. So let's say that we have a squared times a to the third power. So a squared, we can actually rewrite, if you recall, as a times a. That's the definition of a squared. If we have a to the third power, that is a times a times a. So now, if we look at this new expression, we have a times itself 1, 2, 3, 4, 5 times, which is the same as a to the fifth power. Then, hopefully it's clear, 2 plus 3 is equal to 5. So therefore, a shortcut method, instead of rewriting everything like this long-handedly, we could simply, instead of, again, rewriting a squared as a times a, and rewriting a cubed as a times a, we can save ourselves some time and energy by simply adding these exponents. So that would give us a to the fifth power, okay? So the utility of the product rule is to save us some time and energy. So let's go ahead and start with a numerical example here. So let's say I have x to the fifth times x to the seventh power. Okay. Again, if I wanted to, I could rewrite this as 1, 2, 3, 4, 5 x's, and I could rewrite this as 1, 2, 3, 4, 5, 6, 7 x's over here. And then when I counted them up, you would see that there's a total of 12 x's there, which is the same as x to the 12th. Okay, so again, this product rule is giving us a shortcut method to arrive at our answer, and that shortcut is to add our exponents when we have the same base. Okay, so let's look at an example where we don't have the same base. So for example, let's take x squared y to the third. Okay, so if I look at this, right, that would be x times x, y times y times y. Hopefully you recall that x and y are not like terms. Okay, so there's nothing that I can do because as far as we know, x and y are not the same. Now they could be, but we don't know that. They're different letters, right? Different variables, presumably representing different numbers, okay? So there's nothing we can do. Our final answer is literally just to leave this by itself. So please note that the product rule only works when you have the same base. It does not work if you have a different base. Okay, So let's do a few examples from the textbook. So let's say we have, let's see here. Let's say we have a cubed times a to the fifth times, 2 cubed times 2 squared. Let's see if we can simplify this. Okay. So here, right, we have the same base, a and a, so we can rewrite this as a to the 3 plus 5. Okay. Over here, we have 2. 2 and 2, same base, so once again we can add the exponents. Okay, so our final answer, 3 plus 5 is 8, and 3 plus 2 is 5. Now usually in algebra we tend to write our numbers in front of our letters. Okay, and then the last step, and this is important especially if you're using like MyOpenMath. Myself personally, I don't really care if I'm grading an exam. If you wanted to leave it as 2 to the 5th power, I would be fine with that. But MyOpenMath is going to want you to actually evaluate 2 to the 5th power. So remember, on the exams, you're free to use a calculator. But I just happen to know that 2 to the 5th power is 32. So if this were a MyOpenMath question, then this would be your final answer. Okay, I'll write mom here for MyOpenMath. Okay, if you try to type this part, the 2 to the 5th times a to the 8th, if you tried to type that answer into MyOpenMath, I do not believe it would accept the answer. It wants you to simplify any numbers with exponents.